Okay, in this video, we're going to talk about conditionals revisited. We're going to go back and take a look at some more things about arrows. We're going to talk about phrases like sufficient condition, necessary condition, only if, and then we're going to introduce a new rule, conditional proof, aka arrow in. Alright, so for this next set of preparations for quiz 3, we're going to go back to looking at some stuff about conditionals again. Those are arrows. So we've done some stuff with conjunctions recently. That's going to be on quiz 3. The stuff here for this new stuff on conditionals is also going to be stuff for quiz 3 as well. Basically, one new rule is going to be introduced, but also there's going to be some translation stuff that I want you to know at this point too. So first of all, let's talk about the notion of an arrow. Now here's what we've said so far. Basically, it works this way. We got if, and then whatever follows if goes on the left side of the arrow. Then we got the arrow, and then sometimes we have the word then. It's not always there. And whatever is there goes on the right side of the arrow. So if I said something like if A, comma, B, the way we translate that is A, arrow, B. Because whatever follows the word if goes on the left side of the arrow. Okay, great. Now, let's take a look at this again, recognizing some of the parts. So I'm going to introduce some new terms here too. So here's our conditional again. So we got A, arrow, B, and I could put whatever letters here that I wanted to. Now, first thing, here is the, and I've been using this word sometimes, the technical word for the left side of the arrow, no matter what its size, what its size is the antecedent. Antecedent. Literally, that's Latin. The thing that came before. Yep, that's why it's on the left side of the arrow. And technically, the right side of the arrow is the consequent. Okay, like as in like consequences. Literally, consequent, the thing that came afterwards. Literally, the thing that came before, the thing that came afterward. That's pretty easy. Sometimes I've even used those terms. All right, like the left side of the arrow, the antecedent. Okay, the right side of the arrow, the consequent. So far, that hasn't been a big deal. Here's where it is a big deal. All right, in terms of these terms, sometimes the following terms will be used in an argument, and you need to know, hey, this means it's the left side. The word if might not be in there, or it's some of its synonyms that we've already talked about, like should and when. Sometimes this. So here are two terms that are synonyms for these respectively. Okay, so another word for, or another phrase for the antecedent is the phrase sufficient condition. And sometimes we could just say sufficient. Okay, like when we say something's insufficient, we're saying, hey, you get A, arrow, B. Can we get B? Not without the A. Well, I don't have an A. Well, then you don't have the sufficient condition. You have insufficient means to unlock this B right now. Hey, I've got this though. Can I get B now? Yeah, because of arrow out. That's sufficient. Okay, so that's even why we even call that the sufficient condition. So if something is a sufficient condition, that means it's the left side of the arrow. Okay, and I'll look at a couple of examples here in a moment. Now, another term or phrase for the consequent is the necessary condition. So if something's on the right side of the arrow, it must follow. Okay, so if a conditional statement is true, if one thing really leads to another thing, all right, let's say A stands for today is Monday, for example. And let's say B stands for tomorrow is Tuesday. Okay, and then if I put this together, if I say A, arrow, B, one way of saying it is if today is Monday, then tomorrow is Tuesday. Another way I could say it is if today's Monday, necessarily, it must be true that tomorrow is Tuesday. So that right side of the arrow has the sense of mustness or necessity to it. It must follow. It's not kind of like a maybe. It doesn't work that way. Right sides of the arrows are necessary. Sometimes you could use the word essential. I think in generally philosophy, that's probably not a good word to employ here for a necessary condition, but I've seen it be done to say like that this thing is essential. In fact, we'll see it in one of the examples from the book later on. But what this means is, when it comes to this stuff, is that somebody can use the following kinds of expressions when they're talking. Someone could say something like, here, like this. Someone could say, A is a sufficient condition. So A is a sufficient condition for B. How would I write that out? A arrow B. The thing that is the sufficient condition, what's the sufficient condition? A. The sufficient condition goes on the left side of the arrow. Okay? On the other hand, the necessary condition goes on the right side of the arrow. So if I said B is a necessary condition, said B is a necessary condition for A, how would I write that out? Well, necessary conditions go on the right side of the arrow. What is the necessary condition here? B is, so B goes on the right side of the arrow for A. So these two things are actually, I'm saying the exact same thing. If I say A is a sufficient condition for B, if I say B is a necessary condition for A, that's actually the same thing as saying if A, then B. Now there's another phrase here that I want to look out for as well. The dreaded only if. Let's take a look at it. Okay, to review what I've got so far. So the left side of the arrow, that can also be called this thing here. The left side of the arrow can also be referred to as a sufficient condition. And so I could say here A is a sufficient condition for B. I could also, and that's the left side here. Left sides are called sufficient conditions. Right sides of arrows, on the other hand, another name for them is necessary condition. And I'll say the main place where I see this kind of talk, necessary condition, sufficient condition, in my experience, come up the most are like legal contracts. Like, you know when you like download software or go to a website, we use cookies, and you click I agree. Anytime you do those things where you do like let me scroll down and click I agree. Usually that kind of stuff, if you do look at it, actually has this necessary and sufficient language, like what is sufficient cause for you being able to sue them, or saying like necessarily now that you've clicked I agree, you can't sue us for any reason, stuff like that. But that's where you'll see that lingo the most, this kind of stuff, because otherwise it's kind of a weird way to talk. Okay, we, like I said, usually use I could say if A, then B. Here's another way I could put this. So again, here's 4 ways I could put this. Let me start with the ones we know. If A, then B. Whatever A and B stand for. I could say A is, and I'm going to abbreviate here, A is a sufficient condition for B. How would I write that? Same thing, A or B. I could say B is a necessary condition for A. How would I write that? Same thing, A or B. Here's another way I could write this. I could write A only if B. What? Now, look, this is a phrase that gets really confusing. Only if. It looks like, well, hey, you said whatever follows if goes on the left side of the arrow. Why isn't B on the left side of the arrow? Now, this is a very special case, and I kept saying the phrase if. Right, that's because there's this phrase, only if. And you've heard it before. It really shows up in mathematics and sometimes very specific kinds of language. Usually when we employ it, we're actually using it correctly. We just don't think about it too hard. Basically, whatever follows only if is actually the right side of the arrow. Okay, and so here's the easiest way to not screw this up. As soon as you see only if you ever see something like A only if B, here's how not to screw it up. As soon as you see, not if by itself, but you see the phrase only if, just draw an arrow right over it, like this, that goes to the right. Okay, do that. So you see only if, just go, nope, what that means is there's an arrow pointing to the right, and that arrow is going to go right there, and you will never mess this up. Okay? Don't do that when you see if. Like when it comes to this stuff, whatever follows if, that goes on the left side of the arrow. You see only if, just replace it, draw an arrow right over it. Don't. Well, is it if or only? Don't even think about it. As soon as you see only if, just pop an arrow right over it. Now, on the other hand, if you see this phrase, if only, that is just regular if. This only is just there for fun. Just the phrase only if, in that order. You see it, you just replace it with an arrow, because what it's designating is whatever follows it is actually the necessary condition which means the only if is preceding the right side of the arrow. Let's take a look at a couple of examples. All right, let's take a look at my first example here. We've got two simple statements. This is conjoined together here in this. Here's what we got. Being in the city of Aiken, that's just C. Being in South Carolina. Now, two words, but remember, go with the first letter of the capitalized word. So S is going to stand for being in South Carolina. C here stands for being in the city of Aiken. It says this: being in the city of Aiken is a sufficient condition for being in South Carolina. So a sufficient condition, that means one, there's an arrow, and whatever the thing is that is a sufficient condition goes on the left side of the arrow. So sufficient conditions always go on the left side, period. So here, what is the sufficient condition? Being in the city of Aiken. Bam, C. Is a sufficient condition for what? Being in South Carolina. That is just going to be S. So the compound statement, being in the city of Aiken, is a sufficient condition for being in South Carolina, is the same thing as saying, if you're in the city of Aiken, then you're in South Carolina. But notice that does not work the other way around. So here's an arrow that we're not getting out of this. This does not say if you're in South Carolina, then you're in Aiken. That doesn't make any sense. That's stupid talk. Well, I'm in Charleston. Well, then you're in South Carolina, you must be in Aiken. No, so it doesn't work this way. All right, I'm not saying that when I say that something is a sufficient condition. Sufficient conditions go on the left side of the arrows. They're the same. This is another, you could say a more expensive way of saying the word if. All right, so if you're in the city of Aiken, then you're in South Carolina is the same thing as saying being in the city of Aiken is a sufficient condition for being in South Carolina. I guess I could also say with this one, I could say being in South Carolina is a necessary condition of being in the city of Aiken, which means if you're in Aiken, then necessarily you must be in South Carolina. I could think of maybe a few places right on the Savannah River where you technically might be in part of Aiken County, I guess. I guess that's not the city of Aiken. So we'll just say for our purposes here, if you're in the city of Aiken, then you're in South Carolina. That's what this is saying. Let's take a look at another one. All right, let's take a look at another example. This one. Having at least a 60% average is a necessary condition for passing the class. Okay, so here, it's an arrow. Anytime we got sufficient or necessary conditions, because remember, these arrows, they're called conditional statements. They're conditionals. Here we got an arrow, and necessary conditions go on the right. So always, sufficient conditions go on the left, and necessary conditions go on the right. So what is the necessary condition here? So we need to find what is the necessary condition. Having at least a 60% average is a necessary condition. There it is. This thing is going on the right side of the arrow. So having at least a 60% average goes on the right side of the arrow. It's a necessary condition for what? Passing the class. So it gets us P arrow A, which means me saying this, having at least a 60% average is a necessary condition for passing the class, is another way of saying if you pass the class, then you must have had a 60% average at least. Okay, or you must have had, notice that necessary condition, that must have. If you passed, then you must have made a 60 or greater. If you passed the class, then necessarily you made a 60% or greater. Okay, I guess I could also say passing the class, this is a weird way of talking, passing the class is a sufficient condition for having an average of at least 60 or greater. I could say that here. That one sounds kind of sloppy, so I actually think the necessary condition one here works best. All right, now let's take a look at this compound statement here that's made up of two simple statements. You'll be permitted on campus, that's P. P, you'll be permitted on campus. W, you wear a mask. They're put together with this only if. So what do we do with only if? This is what I said to do. As soon as you see only if, just draw an arrow right over it, pointing to the right, and you'll never mess it up. So now what does it say? P arrow W, yep, that's it. So P arrow W. You'll be permitted on campus only if you wear a mask. Okay? So what this means is, if you're permitted on campus, then you must be wearing a mask. Alright, you could say wearing a mask is a necessary condition of being permitted on campus. Okay? That is, if you're here, then you gotta be wearing one. Okay? That's the rule. So that's the way we could say that in a couple different ways. But yeah, only if, don't overthink it, just as soon as you see it, draw an arrow right over it, and that's how you can make sure that you nail it every single time. Okay, so let's take a look at my shorthand here for this. So here's basically, I have a little model here of how I think you can remember this. Here's what I'm going to do of the new three things here: sufficient condition, necessary condition only if. Here's how I remember it. I'm going to write only if here. So here's the deal. When you see only if, I said what to do is draw an arrow right over it. Okay? Where do sufficient conditions go? On the left side of the arrow. Where do necessary conditions go? On the right side of the arrow. So this right here, this is my little quiz 3 diagram for this stuff. Here's all you needed to know. Like, just know this diagram for this. For everything that I've talked about, at least in this video so far. Sufficient conditions go on the left. Necessary conditions go on the right side of the arrow. And when you see only if, just draw an arrow right over it. So it's as simple as this diagram right here. Okay? Now, let's move on to a few new things that we can do with arrows. Okay, now let's talk about another move that we're going to need to use here. So remember, for doing the proofs, we have 3 moves in place. We have the arrow out, okay, which again, the question I said with that is, can you do that? Then do it. Okay, we have the and out. Okay, the question there is, if you got a dot that's not in parentheses, break it apart. And then we got the and in. If you got more than 2 things, you can always put them together, but the question is, should I do that? Okay, so those are the 3 rules that we have in place. There's one more rule that we need to talk about, and this one's a little bit different from these. These are all rules of inference here. We take something and we make something else out of it based on what we've got. This next one here is a little bit different from that. But let's see when we need to use it first. Find ourselves in a situation that things get very heated very quickly. Let's take a look at this argument. Let's say we had this. I got C arrow R. That's an assumption. I've got R arrow M. That's an assumption. I've got M arrow B. That's an assumption. And let's just say here I want to solve for C arrow B. Okay, that's the situation. Okay? So given that, what do I do from here? Well, here's our list. Okay, so we're going to start with this. Arrow out. Do I have any arrows not in parentheses? Actually, I have a ton. Let me go ahead and label these with their numbers too. I have a ton. I have 1 in line 1. I have 1 in line 2. And I have 1 in line 3. Okay, arrows not in parentheses. Now, do I have any left side matches? Nope, there's no C by itself somewhere. Nope, there's no R by itself somewhere. Nope, there's no M by itself somewhere. So, no, I cannot do any arrow outs. Don't despair. There's another rule here. Can I do an and out? Do I have any dots here, not in parentheses? Well, in fact, not only do I not have any dots not in parentheses, I don't have any ands here, period. This is all conditionals. There are no conjunctions. Okay? Then the question becomes, should I put any 2 lines together? Okay, now we can put any of these 2 lines together. In fact, one looks kind of close. We might say, hey, we could put C arrow R and we could put M arrow B together, and then look, at least this one's got a C and a B in it. That's basically the same thing as this, right? And I could say and in 1 and 3. You can totally do that. This is not wrong to do. That's not the correct answer. It doesn't get you. This is not the same thing as this, because there's an R and an M here that aren't here. So that's not correct. Alright, at least in terms of getting the answer. It is a correct move to do. There's nothing wrong with that move. It just doesn't complete it. So look, we did it all. Arrow out, and in. Well, shit, what do I do now? Well, this actually is what we do. This leads us to the next rule that we need to use. And the rule that we're going to use here is actually a theorem, which means we use it only in special situations. So I think of, the other ones that we've used so far, these are like almost like for everyday use. This is something that you might use every day, like a toothbrush or deodorant. Whereas this next one we're going to use, it's more like a fire extinguisher. Probably something that you don't use every day, but you use it in very specific situations. So this is one. So what are the features of the situation going on here? Well, 1, you can't do any of these. All right, or they don't go anywhere. Like, we can do the third one, but it doesn't lead us anywhere. Okay? So that's the first feature here. The second feature is that what I need to look for is my goal, the thing I'm trying to solve for, or the thing I'm after at the moment, is it an arrow? Yes, it is. Look at it. There it is in all its glory. It's an arrow. All right. If it's true that you can't do anything, okay, that leads anywhere, like again, we can do this one, but it's not efficacious. And if that's true, that we can't do anything efficaciously, and our goal is an arrow, we actually have a way out. And this move is called Conditional Proof, or arrow in. Here's how arrow in works. Here's what you do. It's almost like think of it as like a side quest or a subplot to what's going on here. We play it's like a mini game inside the proof that we're doing. So what we do is this. We're going to, in this situation, what you do with the goal here, the thing that you're after, is you provisionally assume the left side of the goal. Okay? And then you get the right side. Now what do I mean by provisionally assume? Well, our assumptions are what we started with. Provisionally assume means let's just play pretend here for a moment and just pretend that the left side of the arrow is true. And let's just see if we can get the right side. Now, the way arrows work is if something's true and you can prove that something follows, then the arrow is a true arrow, which means this is real. And you actually prove this. So in other words, you can prove the whole arrow, the thing that we're actually after, by seeing if this thing were by itself, does it actually lead to this thing? So like I said, though, we're going to think of it as like a mini game or as a side quest. So how do we provisionally assume? So here's what I'm going to do here. Whenever we provisionally assume anything, and there are only two situations, this is literally 50% of all the times you're going to have to provisionally assume in this course. It's either this situation or one other situation that we're going to talk about on the next quiz. Okay, here's what you do. Okay, we get stuck here. So again, here's the scenario. We're stuck. Nope. Nope. Yeah, but it doesn't lead anywhere. Okay, do this. And I indent whenever I do a provisional assumption. So I'm going to say line 4 here. What does it say to do? Provisionally assume the left side of the goal. What's the goal? What we're trying to solve for, C arrow B. So I'm just going to provisionally assume the left side. So I'm going to stick, what's the left side? C. And I'm just going to say provisional assumption, which means it wasn't an original assumption. You could almost think of it as like pretend assumption. Like, let's just play pretend here and see if this works. We're going to basically play pretend, see if this works. And we're going to see if this works in order to get, like the mission was, okay, get the right side of the goal. Okay, so we're saying, if this works, will it lead to this? So I'm going to just put a little tag here saying, all right, the mission right now is get that right side. Do it. Okay. So with this provisional in place, and like I said, we're just going to say, let's see if this just works. The mission right now is not really this, it's get this. The mission right now, the side quest, the subplot, technically the sub-proof, get this thing, get this thing, get this thing. Think about nothing else. With that being said, what we do is now, with this thing, let's just say we can play with this one too, go back to the regular order of business. Can I do an arrow out? Can I do an and out? Should I do an and in? Let's take a look and find out. So those arrows haven't changed. They're still here. Do I have a left side match now with this thing here? I do. Line 1 is C arrow R. I've got a C now. What does that unlock? In line 5 I can say, oh, I get R. What do I do there? Arrow out, 1 and 4. Okay, now we're going places. Now with the R here, do I have a left side match? I do. With line 2, that unlocks the M. I can say there, how'd I get that one? Arrow out, 2 and 5. And now with the M here, what do I get? Is there a left side match here? Yep, between 3 and 6, and gets me B. Arrow out, 3 and 6. Now, think back. When I started this side quest here, I said, I'm going to pretend like C works, and I'm going to see, can I get B? I did. So what I'm going to do here is I'm going to basically draw a little line here along the side, and I'm going to go, side quest is complete. If you start with a C, you will get a B, which means this arrow is true. If C happens, then B will eventually happen. Here it is. You can see it happen eventually. So what I'm going to do here is, this is like the side quest that I indented on. You don't have to indent. I just do it so I can see it right there. But then what I'm going to do is I'm going to zoom back out here in line 8, and I'm going to say, yep, C arrow B is a thing. Okay, yeah, if you got C, it'll lead to B. Now here, this is an arrow in. So we say, yeah, it happened. Now here's what's different. For this one, the numbers are, you're going to cite where did you start the side quest, and all the way to where did it stop. So in other words, where did it start? It started at line 4 when we provisionally assumed the left side. Where did it end when we finally got the right side? 7. So this is arrow in 4 through 7. So this is an arrow in. Arrow in is my nickname for a conditional proof. I guarantee you that you did these in geometry. I remember doing these in geometry in 10th grade, or at least I remember doing something called a conditional proof, having no idea what was going on. Okay, this is what it is. Basically, you just prove an arrow. You say, oh, a conditional statement, it works. Okay, so this is stuff like if you, let's say you had, like in geometry, like you had a triangle. This angle is 45 degrees. Another angle is 45 degrees. Okay, then you know that the next angle is going to be a right angle. All right, because because what's going on there, all the angles in a triangle add up to 180 degrees. So if you had a 45-degree angle and a 45-degree angle, then you know the other one's going to be 90. You can do that as a conditional proof. You can prove it. Okay, that's a geometric one. We're not going to do any with geometry or stuff like that in here. But this is our first example of a conditional proof for an arrow in. Again, what you do when you get stuck, first thing is my goal and arrow. If the answer is yes, pop the left side in there and try and get the right. Once you do that, you can say, yep, an arrow totally belongs in there. We can prove it conditionally. All right, let's take a look at another example with this conditional. All right, let's do another straightforward proof, I think, with that's going to involve an arrow in. So again, here are our options. Here are our situations. Actually, no, not that. We're going to do. We got arrow out. That's the first move. We're going to try that first. Always the question there is, can I do it? Then our next, can I do it? All right, try and out. Okay, the next is, should I do it? Okay, and that's and in. And then the next one here is like its own little separate category. This is arrow in, and it's emergency situations only. Okay, so are you stuck? All right, there's just to say, can't do it in the other ones, do this. And what this says is, if you find yourself in the situation where you can't do any of these other ones, you stuck, is your goal, so is your goal, remember that's the little T on its side, the symbol for goal, is it an arrow? If it is, if the answer is yes, okay, then provisionally assume the left of the goal, get or solve the right. Do that, and then you can stick the arrow in there. So that's arrow in, conditional proof. All right, so let's take a look at this problem. Let's say I've got A arrow B. That's assumption number 1. Let's say I've got B arrow C. That's assumption number 2. And then I'm just going to say, all right, get A arrow C. Now later we'll actually learn a move that'll solve this in one move. Okay, we're not quite there yet, so hopefully you can see, like, if A leads to B and B leads to C, it's almost like cars on a train. If A, like, this is like, you know, if Sunday is before Monday and Monday is before Tuesday, then Sunday is before Tuesday, like something like that. Like, well, then I can cut out the middleman, so to speak. The B is just like a middle term that I can just make A go straight to C. Yep, we're gonna get there, but that's a move that we'll learn how to do that in one move later. Right now we're working on what to do with the moves that we've learned so far. Okay, so that can be defeated by other means later on. That's something that we haven't learned yet. That's something you can unlock later in the semester. So, let's take a look at these. First of all, arrow out. Do I have any arrows not in parentheses? Yep. Both of them. These are arrows, not in parentheses. Left side match? Nope. Left side match? Nope. Moving on. Do I have any dots, ands, not in parentheses? Nope, not today. Should I make an and in here? I can. Okay, I could make A arrow B and B arrow C, but that's not this. All right, so I can do that, but it doesn't lead anywhere. So, are we stuck where we can't do any of the others with any kind of efficacy? Yep, well, then in this situation, here's what we do. First of all, is our goal an arrow? Yep, the goal is in fact an arrow. Okay, when you're in the situation, you start a side quest, okay, little side mission. So what you do here is you provisionally assume the left side. So what we're going to do is we're going to provisionally assume this, Okay, and then we're going to get or solve this. Get this. Okay, you do that, and you can stick the arrow between. You can say this arrow is true. So if you plug this thing in and you get this result, then this works. If this happens, this really will happen. Okay, so you're proving that it works. That's what you're doing. You're basically proving that the conditional really is true. Like if this thing happens, then this other thing will happen. Okay, so let's take a look at this. So that means line 3 here, and whenever I start one of these side quests or provisional assumptions, I indent preference amount. So I'm going to stick this A here, and I'm going to say this is a provisional assumption. It wasn't one of the originals. It's one that we're just playing pretend with it and seeing if it works. Okay, and then this is a provisional assumption with the following quest line. So here's the goal. Here's the mission. Get C by itself. We do that, we can plug the arrow in there, and our work here is done. Okay, now with this A plugged in, we go back to the regular order of business. Can we do this stuff? So now with this A here, can we do an arrow out? Yep, there's this arrow. Now this new A here is a left side match, which gets us B. Arrow out, 1 and 3. Okay, this B actually is the left side match for this line 2, which will get us C. Arrow out. The arrow was in 2. The left side match was in line 4. And by the way, this C we just got, that's the thing that we set off to get. We just got it. So side quest complete. Okay, we did it. Now, what will happen sometimes is people will say, I did it, and they'll stop right here. You finished the side quest, you didn't finish the main quest. Okay, so what you do after this happens is we need to zoom out and say what we did. So let's zoom back out into the main quest and say, all right, what this does here is we want to say, yep, A arrow C, our side quest proved that this is actually a thing. Okay, if you want to, even when I draw this line, when I indent here, if you want to stick a little arrow, make it like this, like you're saying you can stick the arrow in here. If you want to do that, that's fine. So what we're saying is here, that, yeah, A arrow C, it's totally a thing. The arrow in there is legitimate. It works. And then you say, where did it start? Hey, we started trying to prove it in line 3. Where did we prove the end of it? Line 5, when we got the right side, in line C. Now, this proof is done. Now, the next one I want to do is a little bit more complicated, and we'll see why in a moment. So let's take a look at another practice problem where things get a little bit tricky, where it looks tricky. It's actually no more complicated than what we're doing here so far. In reality, it's just going to feel like it's more complicated. Let's take a look at this. Okay, now take a look at this one. I went ahead and got this one a little bit set up for us. So we've got A and B. So this is the first one now. It's got and in it too. A and B, arrow C. Okay, that is our one and only assumption. And then we're going to get if A, then if B, then C. A arrow, B arrow, C. Actually, later on in the semester, again, like towards the end, you'll learn that these actually, you can switch between them. They're actually kind of saying the same thing. Well, obviously, if you can lead from one to the other like this, but actually, they kind of work vice versa. That's something you'll see later on. Like right now, that's not obvious. Okay, so what we want to do is, based on what we know, we want to see if we can get from this to this. Now, it's possible, but let's do it by what we've got here. So first of all, do we have any arrows not in parentheses? Yep. We do, right there. Left side match. The left side is A dot B. Do I have that? I do not. So I'm not getting that C out. That's not happening. Do I have any dots not in parentheses? I have a dot, but it's in parentheses, so that's locked. I can't touch that for now. Can I do an and in? And remember the question there is, should I? Well, not only I shan't, but I can't. Right, because there's nothing else to and in with. So here it's not even a matter of should. I cannot, because there's only one thing. You need at least two things to do an and in. So no, no, no. So of course, what do I do here? Well, is my goal an arrow? Yes, but the arrow again that's in question is the one not in parentheses. There are two arrows up here if you're just looking at it, but my goal, the arrow here is actually this one. The right side of this arrow just happens to also be an arrow. So this is the goal that I'm looking at. This is the statement. This is the conditional statement here. There's its left. So its left side is this. So we're going to end up PAing this. And we want to solve for this. Okay? We want to get this. Okay. So what I'm going to go ahead and do here is I'm going to put here, I'm going to start this side quest. I'm going to say, okay, line 2. Okay, we're going to take A, and we're going to provisionally assume it. Okay, and the mission is get the right side of the arrow, which is just B arrow C. It's a little bit bigger, but that's the mission. Get B arrow C. Okay, with this in play now, can I do an arrow out? No, this is only half of a left side match. Not all of it. Okay? And out. Can I break anything apart? Again, that dot is still in parentheses, so it is unbreakable right now. Now, this time, can I do an and in? I sure can. Should I? Nope. Doesn't get me anywhere. Well, now it looks like we're stuck again. Well, what do we do now? Don't panic. Think about the situation. Is our goal right now an arrow? What is our goal right now? Our goal right now, yeah, we're trying to get this at the end of the day, but our goal right now in this side quest is actually this. B arrow C. So if you're stuck, you can't do anything else. What do? Start a new side quest. So here, we're in a side quest and a side quest. So that means, look here, all we're going to do here is inside our side quest, we're going to PA this, and we're going to try and get this. And if that works, then we're good. If this doesn't work, this problem's not doable, because based on what we know, there's nothing else we could do. Well, let's see. Can we PA the left side of this arrow and get this thing? Let's try it. So I'm going to say here, line 3, a new indentation for a new side quest. B, and this is a provisional assumption. Here, I'm trying to get just C by itself. Now, if I can do this, if I, with the B here plugged in and I get C, then I can say B arrow C is a thing. Okay, so that's what I'm worrying about right now. Now, if I can get that, if I get B arrow C, then I'll prove that A arrow B arrow C is a thing. But let's one step at a time. So here, now with this B here, let's see, now, can I go anywhere? Can I do an arrow out? No. Okay, the left side of this arrow still is A dot B. Now, do I have A dot B? No. Now, you might see right now, I actually have the pieces, but I don't have it like this. So let's just walk through the numbers to make sure we're just doing it this consistently, like always going through this process. Do I have any dots I can break apart right now? No. Do I have anything I should put together? Yes. Finally, I do. Because look, the left side of this arrow, remember, look for, first of all, is my goal a dot? No. Second thing you want to look for, left side's my arrows, any of them dots? Yep. Do I have the pieces to build that? Do I have the pieces to build A and B? Yeah, literally, there they are. Put them together then. Watch this, I'm going to go A dot B. Now that move, and in, I feel like we haven't done one of those in a while. Lines 2 and 3. Okay, so now I've built it. Now can I do an arrow out? Yep, because I just made the left side match. Manufactured it for my own uses. That unlocks this C. Let's go ahead and do that. We get C. What move there? Arrow out. 1 and 4. Now check it out. In this side quest, I said I was going to go after B. I was going to just pretend, see if B works. Can I get C? I did it. There it is. B leads to C. So then I'm going to zoom out of this side quest, our side quest, into our side quest. And I'm going to say, hey, I proved it. If you start with this, it will lead to this. That means B arrow C is a thing. How? How did I prove that? With this thing. Arrow in. Where did it start? Line 3. Where did it stop? Line 5. That's where we got where we PA'd the left side, where we got the right side. So this checks out. Okay? It checks out. Now, here, in doing this now, I actually completed just the plain old side quest. Look, here, remember, way a long time ago, I had provisionally assumed A in order to get B arrow C. I just got it. So here, the way this works when you have one inside another one, usually it works like dominoes. Like, actually, once we got to this part, the whole rest of the thing is just going to just knock down, everything works out. So check it out. Here, I actually fulfilled this side quest. Look, A, you start with A, it actually leads to B arrow C. Side quest complete, which means here I zoom out back into, so to speak, the main quest, and I can say here, yep, took a while, but if you start with A, you will actually get B arrow C. Look, that's the goal that we wanted. That's the thing we wanted. Now, how did it happen? Here, it's this. We did an arrow in there. You can actually stick an arrow in between this thing and this thing. Where did this one start? This one we actually we made the provisional assumption of A in line 2. Where did it stop? Well, we got the right side in line 6. So 2 through 6. Bam. So this one, there was a Technically, I've been saying side quest, but it's a subproof inside a subproof inside a proof. But even when we got stuck right here, we still only use one of these four things. Still, all of the problems here on this quiz, and really, there's no more. This is it. This arrow out and in, or in emergency situations needing the arrow in. Now, since we're first learning the arrow in, there'll be plenty of those because we're learning this when it's new. But it's a theorem. It's sort of like for emergency use only. It's not a rule of substitution. Certain conditions have to, that's why it's conditional proof, certain conditions have to be met to even use it. That's what makes it a theorem instead of just a regular rule, I suppose. So let's take a look at another proof now. All right, another practice one. And then we'll get into some more of the problems that are in the pages of the book too. All right, let's take a look at this one. This one's actually very similar to the last one, but just in reverse. Okay, and it actually ends up being less complicated. All right, so let's go ahead and start it here. Now, I've also condensed my list a little bit. You can refer to the basic rules of formal logic if you want a more detailed set of what these things do. But just to save myself some room here on the screen and on this board, I'm going to just make this a little bit like a shorthand. When we need to employ them, I'll remind us of what's going on. But that'll just save me a little of this space here, now that we've been doing this for a little while. So let's start with this one. This one, all right, again, first thing to do. Arrow out. First of all, do I have any arrows not in parentheses? This one. Okay. Do I have a left side match though? Nope, because this is only one assumption. So no. Moving on. Do I have any dots not in parentheses? No. Moving on. Do I have any anything that I can and should put together? Not only shouldn't I can't put anything together because I only have one line. So in this situation, what do? First of all, we look and see, is our goal an arrow? Well, of course it is. There it is. Later on, we will find situations where that doesn't happen. It's not an arrow, and we have to do something else. We're not there yet. That won't happen on this quiz. So yeah, our goal is an arrow. So what do we do in this situation? We provisionally assume the left, which this time is a little bit heftier, and we're going to want to get the right in a side quest. Let's do that. So let's indent a level, begin our side quest. So we're going to provisionally assume the left side of the arrow of our goal. That's A and B. That's a provisional assumption. But the mission here in the side quest is to get the right side, which is C. So get that, and then we can stick the arrow in there. And then we're actually going to be good. All right, so let's do it. Now, with this dot here, can we do an arrow out? No. Okay, the stuff is together. Now look, do we have any new dots not in parentheses? Yes, we do. Right there. So what can we do to those? Whenever you see a dot not in parentheses, slice it right in half. And that gets you some new bits. We get A and B separately. But how? And out on line 2 for both. Okay, cool. Now go back to the top of the list. Can I do an arrow out now? Do I have a left side match now? Yup. This left side match is going to unlock this right side of the arrow right here. So that gets me in line 5. B arrow C, which has now itself been freed from the parentheses. Again, where's the arrow? The arrow was in line 1. Where's its left side match? Line 3. And look, this is like teed up perfectly for us. Take a look. Go back to the top of the list just to make sure. Do I have any new arrows not in parentheses? This one. Okay. Does it have a left side match? Literally right next to it. Okay. What does that do? That unlocks the right side, which is C. What move did I use there? Arrow out. Okay. Where was the arrow? Line 5. Where was its left side match? Line 4. And look, that's what we set out to do. We said we were going to try. If we got A dot B, will we get C? Oh, yes, we will. So now I can say side quest complete. So now I'm going to zoom out here, back into the real world, main quest, and I'm going to say, yeah, this is totally a thing. If you start with A dot B, because this is literally what a conditional proof is saying. If you start with this, then, that means here's the arrow, then you will get this. Well, how do I know that? Prove it. That's what this is. If you start with this, then you will get this. This is just the shorthand of saying this. Okay? And where did this happen? We want to show our receipts. That was arrow in. Where did this start? Where did we provisionally assume the left? Line 2. Where did we get the right? Line 6. And this problem is now complete. Okay, so I think I want to do one more. Yeah, I'm going to do one more of these like practice ones, and then we'll look at some directly out of the book that you can look at too. Okay, let's take a look at this one. This one we got A arrow, B arrow C. That's our one and only assumption, and we're going to go after B arrow, A arrow C. Okay, a lot of the same letters. It looks like they're just kind of mixed up, but remember, they're all arrows. It's not dots. So if there were dots, there's a way we could break these apart very easily and just move them around. Not what's going on here. It's all arrows. Let's see. Does this one lead to this? So first of all, let's practice this. We have any arrows not in parentheses? Yeah. Left side match? We can't because we only got one item. Any dots in here? Not at all. Anything to put together? No. So, and this has been a pattern here so far at this point. Is our goal an arrow? Yes. So what are we going to do? We're going to PA this, and we're on a mission to get this. Okay, let's try it. So indent a level. Start our side quest. We're going to say, all right, let's pretend that B works, and then we're going to go on a mission to get A arrow C. Cool. Now, with that in play, let's try it. Can we do an arrow out? No. You might be thinking, hey, it's the left side of this arrow. That was in parentheses. It doesn't work. Can I do an and out? Nope. No dots. Still. Can I do an and in? I can. Does it go anywhere? No. So, remember, what's the goal right now? The goal right now in the side quest is A arrow C. So ask this question. Is my goal an arrow? This is my goal right now. So yes, it is. Alright, so in this situation, what we do, we're going to start another side quest. We're going to PA this thing. And we're going to go and get this thing. Alright, so that's going to be the mission right now. We're going to PA the left of our goal. So the left side of our goal right now. New side quest. Side quest. This is our new provisional assumption. And the mission for this side quest is to get the right side there, which is just C. So right now we get C. Now, the way these work, though, like I know it seems more complicated when you have like one inside another one inside the main one, but actually once you get this, the first thing, everything else, like I said, it's like a domino effect. Everything else is just smoothly lines up right after that. So let's go on a quest after this now. We get C, everything else will just unravel from there in a good way. So now with this A here, now can I finally do anything? Can I do an arrow out? Yup, finally. There it is. There's a left side match. Now, it's in 3 layers deep, but here it is. Also, I'll just say this at this point. Maybe I should have said this earlier. If you look at any of these proofs online, like if you Google some stuff on Logic, a lot of logicians make it that when you start one of these subproofs or side quests, that you have to copy and paste the stuff that's on the outside inside the other ones. And that's a rule called reiteration. So just if you see it, that's what it is. I don't do that. I think it's obvious that if it's out here, it can also be in here. Okay. To me, that seems to be obviously true. Okay, so I don't think it needs to be like copy and pasted into each subproof before you can use it. But that is a thing that some logicians do. Just to, if you ever have another logic class elsewhere, or if you look this stuff up online, you might encounter that reiteration rule. That's what's going on there. But I don't do it. So in other words, before I could do an arrow out there, they would say, you have to line 4 copy line 1 into the subproof in line 3, and I'm just not feeling that. So, do we have a left side match between line 1 and 3? We do. So that's going to unlock this. That gets B arrow C. That's arrow out 1 and 3. Cool. Now look, I got a new arrow. Not in parentheses. Does it have a left side match? It sure does, right there. What's that going to unlock? The C. By the way, this is the thing we were after in the moment anyway. So watch, this one, even though it's a side quest, inside a side quest, inside the main quest, or again, like a subproof inside a subproof inside a regular proof, everything here is just going to unlock. Now, it's just going to go boom, 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 and everything's done. Like, as soon as I write the C here, watch. So look, C. Arrow out. Where was the arrow that we just used? Line 4. Okay. Line 4. Where was its left side match? Line 2. And here's what I mean. Look, we started out, we were on a quest. That when we provisionally assumed A, we were after C. That happened, which means we can zoom out now and say, yes, it is true. If you start with A, you will get C, as we set out on a quest to do here. Okay, what did we do here? We stuck an arrow between line 3 and ultimately line 5. There it is. Now, hey, look, but we got A arrow. We said earlier that we were plugging in B to get A arrow C. Did it happen? Yeah, it just did in line 6. So this side quest is actually now complete because the one inside it is complete. But watch this. To say this one, so this side quest was done, so we can zoom out and say back into the main quest, hey, if you have B, then it leads to this other thing, namely A arrow C. Oh, by the way, that's the goal that we're solving for. It all worked out in the end. Okay. What move did we do here? We did an arrow in. Where did we start by provisionally assuming the left side? Line 2. Where did it end? Line 6. And so now this proof is also done. All right, let's go ahead and do another proof. This one's a little bit longer. Okay. And so here, what we're trying to do is we've got A arrow B, we've got C arrow D. We're trying to solve for A and C, arrow B and D. Let's give it a shot. So first of all, do we have any arrows not in parentheses? Oh, very much so. This one and this one. Left side matches for either, though. Nope. Any dots not in parentheses? Nope. Can we put two things together? Yeah, and even though it looks really similar, this thing here that we could make, A arrow B and C arrow D, like someone might accidentally think and in 1 and 2. Like, that's not wrong. You can do that. That's not wrong. But even though it has all the same letters, this is not the same thing as this. Okay? The letters aren't in the right order. There's a dot here. There's an arrow there. It's not the same thing. So you can do it. It's not illogical. It's not mistaken. It's perfectly valid. It's just not what we're after. Okay, so then comes the next question. We've been doing a lot of these lately. Right? Is our goal an arrow? Yep. So what do we do in this situation? PA the left. Get this. You do that, you can prove that this thing's an arrow. So that's what we're going to do. So this line 3 here is going to be a little indented. So that means we're going to have here we're going to say, and it's going to be the left side's a little bit bigger. So we're going to say A dot C. So line 3 here, A dot C. That's a provisional assumption because it's the whole left side. It's freed from its parentheses though as a result. And the mission is get B and D. That's the mission. All right then. Let's see if it's doable. All right. Any left side matches? No. So can't do any arrow outs. Do we have any dots not in parentheses? Yeah, this is new. Let's cleave that in twain. What two things does that get us? A and C separately. Okay, and now watch this. Are there any arrow outs that we can do now? Yeah, actually two. There's a left side match. There's a left side match. So we can unlock both these things. Okay, which one do we need to do first? It doesn't matter. I like to do whichever one comes first. So since the first arrow there is literally in line 1, I'm going to deal with that one first. A is a left side match here. That's going to unlock B. Arrow out. 1 and 5. And then here we've got a left side match between 2 and 5. Okay, that's going to unlock D. So arrow out. 2 and 5. Okay, all right, so I've done some arrow outs. Go back to the top of the list. Any new arrow outs? Any new arrows to deal with? No. Any dots I can slice apart? I already did that one. Okay, is there anything I can build? I can mix any of these 7 things together. Okay, but the question is, should I build anything? Remember, what's the goal right now? The goal right now is B dot D, and I said 99% of the time, if your goal is a conjunction, if it's a dot, 99% likelihood that the move you're going to do to get that is an and in. There are exceptions. For example, if I said I got A arrow B and C, okay? I've got A. Well, now I get B and C. Here it is. I got an and statement, but I didn't do an and in. So there, I got it through an arrow out. So I'm saying it is possible. But most of the time, 99% of the time, that's not an exact number per se. I'm just saying most of the time, if you need to make a conjunction, if you need to make an and statement, you're probably going to do adjunction. You're going to make an and in. Well, so our goal is B dot D, B and D. Do we have the pieces to build that? Do we have B by itself? Right here. Do we have D by itself? Right here. Well, we got the pieces to make it. Let's build it. So yeah, we can totally get B dot D and in. Where were those pieces? 6 and 7. Hey, We got the right side we were looking for. Side quest complete. So now we can zoom out back into the main quest and say, yeah, A.C, yeah, if you have that, then you will get B.D. Yeah, you can totally stick an arrow in there. I can prove it. How so? Well, we proved it by starting with 3. We got an 8. And this proof is done. Let's start now on some of the exercises that come a little bit later in the book. Namely, I'm going to look at some of the problems that start on page 51. So we're going to look at a couple of the translations on 51. I'm going to deal with those first, and then we'll proceed through the problems on the back end of the chapter. And then I'm going to do a couple of problems from the upcoming quiz here too. Like I'm going to give you a few sample ones, give you a feel for like, yeah, here are the ones in the book, and what are the ones going to be like on the quiz as well. So we'll be doing that shortly too. What I want to do now is take a look at a couple of the translations out of the book. These are on page 51. So this is number 1. Let's take a look. Let's take a look at A, B, C, D, and F. All right, so let's start with A. The Heat makes it to the playoffs only if the Hawks lose to the Cavs. All right, there's that only if. Remember, as soon as you see it, put an arrow right through it. Okay, but as soon as you see that only if, put an arrow right through it. And so when I read that back, the Heat makes it to the playoffs. That's M, and then right there, arrow. Only if the Hawks lose to the Cavs. So what this is really saying is, if the Heat make it, then the Hawks have lost to the Cavs. Okay? B. You're having a quiz average over 90 is a sufficient condition for being excused from the final. Okay? Well, sufficient condition means there's an arrow. And sufficient conditions go on the left side. So you're having a quiz average over 90 is the sufficient condition. So this thing goes on the left side for being excused from the final. Which means this is saying if you have a quiz average over 90, then you're excused from the final. C. Now be careful here. Only if we can attract readers of your caliber in these early days of the Saturday Review education can we publish the magazine we have in mind. Now notice the first words in the sentence are only if. Now what I say still stands. If as soon as you see only if, just draw an arrow right over it. So what follows the only if? Only if we can attract readers of your caliber in these early days of the Saturday Review education. The can we publish? That goes on the left. So what this is really saying is, if we can publish the magazine we have in mind, then we can attract readers of your caliber. Okay? So if we can publish what we want, then we'll attract readers of your caliber. Okay, not how I would have worded that, but nevertheless, that's what's going on there. And still, the rule about only if applies. When you see it, just draw an arrow right over it. Okay, and now let's take a look at D here. Okay. Aquinas thought that the fact that the intellect is under the control of the will is a necessary condition for the existence of intellectual virtues. Okay, it's a necessary condition, so it's an arrow. And necessary conditions go on the right side of the arrow. So Aquinas thought that the control of the will is a necessary condition of the existence of intellectual virtues. Okay. This is out of Aquinas' disputed questions on the virtues. Okay, so yeah, if there are intellectual virtues, then the intellect is under the control of the will. That's a little medieval philosophy for you. And then finally here, let's take a look at F. I don't like it. I don't like, this one's trying to trick you. I'm not going to give you one like this, but I'm just going to say this one is trying to trick you. Okay, it says, Hannah could save the company if only the president would promote her. So at first you might go, oh, yeah, there's an only if. Let me draw an arrow right over it. There is not an only if there. It said if only. That is not the same thing. The only if means cover that up with an arrow. You see, if only, that's only, like the only there is doing like a It's modifying the if. Like, if only, like, you're wishing really hard. Like, I really wish this if. But that's all it's doing. It's not the same thing as only if. So that means here, we're dealing with an if. And whatever follows if, just plain vanilla if, goes on the left side of an arrow. So there's an arrow here, and whatever follows that. So what follows the if? The president would promote her. If only the president would promote her, Hannah could save the company. So if only they promote her, then she'd save the company. So she could save the company. So if she gets promoted, then she'll save the company. Okay? That's A, B, C, D, and F. There's a reason why I'm not doing E, and I don't really want to get into it. So let's take a look. The other ones I want to take a look at are H, I, and L. Let's go ahead and get into those as well. Alright, these next three are a bit more complicated. H, I, and L. And there's some others here that I'm skipping because they're more complicated than they need to be for our purposes. So H, I, and L. Let's take a look at H. It says this. If he is really determined not to run, okay, we're ignoring the negations for now. We haven't talked about them yet. If he's really determined not to run, and if he wants to see the nomination go to someone who shares his viewpoint, then he should announce now that he is not a candidate. So what I see here, just on a cursory view, I see two ifs and a then. That's actually a hint. Okay? The statement is really, there's an arrow in here, so let's go ahead and stick that in there. Now, two ifs and a then. Okay, I'm just going to say this. If you see two ifs and a then, that means you got an arrow, and usually the left side is going to be two things. Okay, let's see, especially if there's an and in between them. Okay, so if you see if one thing, blah, 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 and if another thing, blah, 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 then you're going to have a shape that looks like this. Okay, something and something, arrow, some other thing. Let's see if that's what's going on here. Okay, if he's determined not to run, and if he wants the nomination to go to someone who shares his viewpoint. Yep, there we go. If he's determined not to run, and he wants to see the nomination go to someone else who wants to share his viewpoint. So if he wants both these things, then he should announce that he is not a candidate. Okay, that's what's going on here. So if he wants this and this, then he should do this. That's what's going on with this one. Okay? So let's take a look at I. I says this. Now this is the kind of stuff that actually does happen in, like, if you ever wondered, like, playoff math, all right, or not just math, it's actually it's complicated logic proofs, all right, to figure out, like, if this team wins and this other team in the division loses and then this other team wins here, then that means this team is going to be the wild card team, that kind of thing. Okay? Those kinds of things. How does that work? It's actually a complicated logic problem. The way the BCS system used to be as to what team would play in what bowl was even more convoluted. But that's what's going on here. So let's see this in practice. So look at this. It says, should the Dolphins win their division and defeat the Western champion? Remember, should means if, which means there's an arrow in here. And that comma, by the way, after champion means the then is starting now. It doesn't say the word then, but that's it. So everything that just said so far is on the left side of the arrow. So what do we got? If the Dolphins win their division and defeat the Western champion. So if they win their division and they defeat the Western champion. If both those things, well then what? Then the American Conference title game will be held in Miami January 2nd only if the runner-up team beats Cleveland. There was an only if in there. So first of all this stuff is going to be together. We saw only if, put an arrow right over it. Be ye not tricked. And then write it exactly as it is. So what only if what? It says Miami only if, draw that arrow, runner up. Okay, now I'm going to read it back in a little bit more of a conventional way to check it. It's saying this. Okay, if the Dolphins win and they defeat the Western champion, then if the game's in Miami, then the runner-up team has beat Cleveland. That's what's being said here. Okay, and this is correct. So like I said, there's another example. Only as soon as you see only if, pop that arrow right down. Don't think about, well, does it go this way? Just draw an arrow right there. I've literally done that in my book. Myself. I just draw the arrows right there on top of the words only if. You won't mess it up. Then finally, let's take a look at L here. It's not a particularly great one, but we'll do it. L says this: a prosperous, democratic Latin America is essential to hemispheric well-being. Mm-mm-mm. One more time. And this one's not really tricking you. It's just not clear based on the word that we've used so far. Okay, but we'll see if we can figure it out. A prosperous, democratic Latin America is essential to hemispheric well-being. So here's what I don't see. I don't see a sufficient condition. I don't see only if, and I don't see necessary condition as such. Well, I said as such that because there is a word in here that's actually hinting at which one of those conditions is going on. I'm going to say this. The word is essential. So what's a synonym for essential? Necessary. So when it says here that a prosperous, democratic Latin America is essential to hemispheric well-being, it's very subtly saying a prosperous, democratic Latin America is a necessary condition for hemispheric well-being. That was tricky. Now I'm not going to do that to you on a quiz, but I just want you to, again, this is another example. Just know this stuff is out there. Not everybody tries to write their things clearly so they can be put into formal logic. Okay? But if we can figure out with formal logic what's actually going on, that can help us gain clarity in figuring out do these things actually work. Now, so far with all the proofs we've done and whatnot, everything works. Now, actually, towards the end of the semester, we're going to look at cases where we can figure out, well, does this work or not? We have like ways that we can test. Like, does this work? Is this valid? Or am I just missing something? Okay, did I mess up, or did the maker of the argument mess up? We'll look at those checks later on in the semester. So let's try and actually translate this one. So again, that prosperous, democratic Latin America, that's a necessary condition, which means it goes on the right side of the arrow. What goes on the right side of the arrow? Prosperous, comma, democratic Latin America. And it says this one has a glossary. P stands for Latin America prospers. D stands for Latin America is democratic. Well, it says a prosperous, democratic Latin America is essential. So that comma there is actually doing the work of a conjunction. So what it's saying here is, what's a necessary condition? These two things. This and this, P and D, are a necessary condition for hemispheric well-being. They are a necessary condition for W. So what does that mean? If you've got W, then you've got these two things. That's what this is saying. So if you've got hemispheric well-being, then Latin America must be prosperous and it must be democratic. Otherwise, you don't have this. We'll talk about that aspect a little bit later on. Let's now take a look at, as we've done so far, the number 3s, 3A, B, C, and D, and the way that they get done in the book. Like I said, the author of your textbook kind of does this little fill-in-the-blank kind of thing that I don't do. I'm just going to do them straightforwardly as I give them to you. Let's take a look at those, 3A, B, C, and D. All right, let's start with 3A. So I went ahead and got, here's our premise up here, A arrow B. It's our one and only assumption. We're solving for this thing. We got A arrow A dot B. That's what we want to get. Okay, so first of all, do we have any arrows? And here's our cheat sheet of our 4 moves that we've got that we need to try out in this order. So you can actually do this in different orders. This order here will always get to use the most efficient results. In fact, later on, as we start adding more and more moves to our list of things to do, I'm going to have a recommended order for you to do it. If you do the recommended order, you'll always get the most efficient results. Okay, if you go out of order, you will find yourself in situations where you're doing things that take longer. Okay, kind of like instead of making a left turn at a block, maybe you could make 4 right turns and end up in the same situation. Like you could end up at the same destination, but that's the long way to do it. This way is always the most efficient way to do it. Okay, when I give you an order like this. So let's see. Do we have an arrow here? We do. Not in parentheses. Do we have a left side match though? No. Any dots that we can break apart? No. Anything that we can put together with a dot that we should? Neither is there something to put together, nor can we. Okay, nor should we. There we go. So then we move on to this one. Arrow in. Is our goal an arrow? Yes, it is. Which means we're going to PA the left side, and we're going to try and get the right side. We do that, we can stick that arrow in there. Let's begin our side quest. So here in line 2, we're going to stick the A up there as a provisional assumption. Provisional assumption for getting A dot B. Okay, do that, the whole thing will unravel. Okay, so Now, do we have an arrow out? Yep, we got a left side match, which means we get B, arrow out, on D. Okay, so now, so check it out. Now, do we have an arrow out? Nope, we already did that. Do we have any dots that we can break apart? Nope, there were none. Do we have anything we should build? Well, look, we've got A, we want to get A dot B. So this is, again, one of those situations where I said 99% of the time, if you're trying to get a dot, you're probably going to build it with the pieces, with an and in. Do you have the pieces to build this? There. There they are. Build it. A dot B and in 2 and 3. And look, side quest complete. We did it. We provisionally assumed the left. We got the right. So now we zoom out. And we just say that's what we did. You get this thing, or you provisionally assume this, then you will eventually get A dot B. But how? With the power of arrow in. Where did it start here? We provisionally assumed the left side of the arrow in line 2, and we were able to get the right side of the arrow by line 4. This one's now done. Let's take a look at 3B. Alright, here's 3B. We've got C arrow D, C arrow E. Those are our only assumptions. And we want to get C arrow D and E. Alright, so let's see if we can do that. So first of all, can we do any arrow outs? Do we have any arrows not in parentheses? We do have arrows not in parentheses, 2 of them. We don't have a left side match anywhere. Okay, do we have any dots that we can break apart? Nope. Do we have anything that we can and should build with an and in? We've got stuff we can build, we have nothing that we should build. Okay, we end up getting like C arrow D and C arrow E. Well, it's close. No. Can't you just smush these together into this? No. No. So, what do we do? We see, is our goal an arrow? It sure is. So what do? Provisionally assume the left side. Solve for get the right side of our goal. So we're going to start our side quest here by zooming in. Line 3. I'm going to provisionally assume that left side. So I'm going to say, hey, let's provisionally assume that. And let's try and get D dot E. Okay, so that's the mission. Get this right now. Get D dot E. Okay. So now with this C here, can we do an arrow out? In fact, we can do 2. Does it matter which one I do first? No. So I like to do them in the order that they come, so I'm going to start here first. So it's the left side match for this, and it's the left side match for this. And remember, the lines when we use them, they have infinite uses. Okay, so they don't run out. So just because we use it once doesn't mean, oh, well, we use it, we can't use it again. Infinite uses. So here, left side match, we get D. That's arrow out. The arrow that we used here is line 1, and the left side match is in line 3. Now we also get a left side match here with line 2, and that gets us E. Okay, also arrow out. This time not 1 and 3, but 2 and 3. Okay, now, can I do any more arrow outs? Mm-mm. Can I slice apart any dots? No. Can I build anything with some dots? Take a look. We're trying to get D dot E. And it's another one of those times where I said most of the time, if you're trying to get a dot, you're probably going to build it with the pieces. There are the pieces. Put it together. D dot E. And in. 4 and 5. Okay. So side quest complete. We did it. We provisionally assumed this. We got it. So then we zoom out. And we just say, yep, that's a thing. If you start with this, you will get this. And that's a little move called arrow in. Okay. This started for us in line 3. We were done by line 6. This one's done. Let's take a look at 3C. Alright, let's take a look now at 3C. So here's the situation. We've got this. F arrow G arrow H, parentheses around the G arrow H. Want to get G and F, all that, if all that, then H. Okay, so let's start with what we've got in terms of assumptions. Arrows not in parentheses, only one. This one. Do we have a left side match? Nope. Any dots to slice apart? Nope. Anything to build? Can't. So then, is our goal an arrow? Yes. So what are we going to do? What we've been doing. We're going to provisionally assume the left side here, and then we're going to try and get this H thing. That's the mission. Okay? So let's start that side quest. So I'm going to say here in line 2, hey, we get g.f as a provisional assumption. Okay, it's freed from its parentheses when we do that, and we're on a quest now to get just h. We do that, the whole thing's going to unlock. Okay, now with this g.f here, do I have a left side match? Nope. Do I have any dots that are here that are new that I can slice in half? Yep, this is new. So slice it. That gets me two things. G, F. Both of these are the result of an and out on line 2. We just slice that thing right in half. Okay, now do we have any left side matches? Yeah, look at line 1. That left side is F. Now we got an F. What does that do? That's going to unlock the right side and free it from its parentheses. So I'm able to say in line 5, oh, we get G arrow H now. That's arrow out. Where was the arrow that I used? Line 1. Where was its left side match? Line 4. Cool. So now I got G arrow H. Oh, that's a new arrow. Let me go ahead and mark that. Okay, do I have any new left side matches though? Left side of this is G. Do I have a left side match? Right there. This enables me to unlock the right side, which is H, and I get that via arrow out. The arrow that I used was in line 5. The left side match was in line 3. And look, I set out what I intended to do. I said I was going to start by provisionally assuming, just pretending. If we get G and F, will it lead us to H? Yep, it sure does. There it is. So now I can say side quest complete. Now I zoom out now, and I say line 7. Yeah, if you start with this, then it will lead to this. And that can be proven with an arrow in. Okay? Arrow in this case, it started in line 2, because that's where we provisionally assumed the left, and it ended in line 6, because that's where we got the right. Alright, and now finally, let's take a look at the same thing in reverse. Alright, so we're going to start with this one as an assumption, and then we're going to get this in 3D. Sounds cooler than it is. Okay, let's take a look at 3D. We got G.F arrow H, and we're after F arrow G arrow H. Let's give it a shot. So first of all, arrow's not in parentheses. Yes, we have one. Do we have a left side match? G.F? No. Do we have any dots not in parentheses that we can break apart? We do have dots here in line 1. Can we break them apart? No, because they're in parentheses. Do we have anything that we can build? No, because we've only got one item. So that leads it to the arrow in move. Is my goal an arrow? Yup. So what am I going to do? I'm going to provisionally assume the left side, and I'm going to try and get the right side. That's the plan. So let's start the side quest. Line 2, we're going to provisionally assume F, and the mission is get G arrow H. So this one, is this a left side match? No. Any dots that I can break apart? No. Anything that I can build? Yes. Should I build? No. So in this situation, again, what you do, look and see, before you start getting frustrated, is my goal right now. My goal right now is G arrow H. Is it an arrow? Yeah. So in this situation, we're going to start a new side quest. Provisionally assume this. Get this. Okay, because our goal at the moment is also an arrow, so we're going to do the same kind of stuff. So it's a new side quest. So let's zoom into this. Line 3, we're going to go, okay, if we have G as a provisional assumption, then will that get us H? So that's the mission. Okay, and this is one of those, since it's a side quest inside a side quest inside a main quest, once you get the H, the whole rest of the thing falls down like dominoes. It's good to go. Let's see if we can do it. So, do we have an arrow out now? No. Hopefully you can see that we do have the pieces to build it. Any dots we can slice apart? No. Is there an and in we should do? I was already hinting at that. Look, so the left side of this arrow is G.F. Do I have the pieces to build it? Yes, I do. So let's go ahead and build it. G.F. That's and in 3 and 2. Why 3 and 2? Because that's where the pieces came from. G came from 3, F came from 2. Now can I do an arrow out? Yep. This is a left side match to this, which means it's going to unlock the H. Arrow out, 1 and 4. Now remember what I said. I said once we get H, the whole rest of the thing is just going to boom, boom, boom. Like dominoes tumbling. It's all going to fit together immediately. So watch this. We said if we provisionally assume G, we're going to get H. Mission complete, which means we zoom out and say that that happened. Okay, we started with G, we got H. Okay, how? We stuck an arrow in there. We started in line 3, mission accomplished, line 5. And that zoomed us out. Then remember, we also said earlier we're going to provisionally assume F, and then we're going to see if we can get G arrow H. We just got it. So look, this side quest is complete. Okay, as a result, which means we can zoom out here and say finally, yeah, if you start with F, then you will totally get G arrow H. Yep, you can totally stick an arrow in there. Where did we start in our quest? We started by provisionally assuming the left side in line 2. And where did we get the right side? Line 6. And now take a look. The problem is done. Side quest, inside of side quest, inside of main quest. But again, when we got stuck, it was just a matter of, in that situation, do what you're supposed to. Is our goal an arrow? Provisionally assume the left, get the right. We did that here. That got us out. We started to do that here, and that, bam, that solved the problem. Okay, so now let's take a look at a couple of the translation problems. Now, some of these I'm going to skip because I'm not particularly partial to them. But we'll do a few of these, and then we'll get into some actual problems from your quiz here as well. Okay, let's now take a look at number 7 here. This is on page 54. There's the italicized argument, and then let's actually get to the actual thing. Here's what it says. This one's weird. It says this. If you flinch, I'll kill you. Okay, so if means there's an arrow in there. And so if you flinch, then I'll kill you. Delightful. That's our first assumption. Second assumption, and if I have to kill you, I'll kill her. Now, it starts with and, but since it starts with a superfluous and, there's no dot going on there because it wouldn't be well formed otherwise. So if I have to kill you, I'll kill her. Assumption. Therefore, so this is what we're solving for. Therefore, I'll kill both of you if you flinch. So, if you flinch, I'll kill who? Both of you. How do I say that? You and her. There's a certain sense here in that it's ambiguous where I would accept F arrow H dot Y. That would be fine too. Because it's not clear in the both, like which one comes first. I'm just doing it because this is the first one that came. So let's do this problem. So the translation is done. Let's do the work. First of all, arrow out. Do we have any arrows not in parentheses? Yeah, we got 2. Okay. Do we have any left side matches here? No. Any dots we can break apart? No. Anything we should bring together? Again, we can bring these two together. Should we? No. So then we do this. Emergency situation. Is our goal an arrow? Yes, it is. So what are we going to do? We are going to provisionally assume this. And then we're going to try and get this. Provisionally assume the left side, get the right side. So let's do that. Let's indent as we start our side quest. So we're going to provisionally assume F. Okay, provisionally assume PA. Let's just see if this works. And what we're after, right now the mission right now has become get Y and H. Okay, so this is one of those things. I see it right now. I'm going to go ahead and say this. It's a dot. So 99% likelihood what we're going to do is we're going to have a Y and H and put them together with an and in. Okay? That's probably what's going to happen. So let's do the work. Do we have an arrow out now? Yeah, we got a left side match here. And that unlocks Y. Arrow out. Where was the arrow? 1. Where was this left side match? 3. But now with the Y, we have another arrow out that we can do, which is going to unlock the H. H. Arrow out. Where was the arrow we used? 2. The left side match, line 4. Okay, now, can we do another arrow out? Nope, those have all been done. Can we do an and out? Are there any dots to separate? No. Alright, so is there anything we should build? Well, I was already saying, like we're trying to get a dot. Do we have the pieces to build it? We need Y and H. Do we have those pieces? Yep, we just got them. Put them together. Y dot H. And in is the move. Where do those pieces come from? Lines 4 and 5 respectively. Hey, we got the thing we were trying to get in the side quest. mission complete. So then we zoom out, and we say, yeah, if you have F, thing we're trying to get, if you have F, it will lead to Y and H because of this move. You can stick an arrow in there. Where did it start? We started in line 3. Where did it end? It ended in line 6. Okay, let's take a look at the next one. Right, now let's do number 8. So this one is found, the actual one that we're going to be translating is found on page 55. Let's get into it. It says this. Now, Little John will be eligible if, which means we've got an arrow here. So the first line, it's an arrow. He will be eligible if. Now this means already the eligible is on the right side of the arrow, and whatever follows if is on the left side. And it gives us numerals here, so it says if 1, so count up how many numbers there are. There's 1, there's 2, that means there's 2 things on the left side of the arrow following if. If 1, he lives in the Asheville district, what's the next word? And, so here we go. Before I even start filling anything else in, I know there's 2 things on the left side of the arrow connected with an and, with a dot. What's the first thing? He lives in the Asheville district. And his uncle is awarded custody. Great. So he's eligible if he lives in the Asheville district and his uncle is awarded custody, then he is eligible for whatever it is that we're talking about. Now you notice the next punctuation mark that comes is not a period, it is a semicolon, which means this is not done. Then it says semicolon and, which means we need brackets. Brackets are just super parentheses. It just means this is all a unit and there's more coming. And what? And he does live in the Asheville district. So no, really A. Okay, that is our first assumption. Okay? In fact, that is our only assumption. Because then it says, it follows that, that means here's what you're solving for. What are we solving for? It follows that he will be eligible if the uncle is awarded custody. So we're solving for an arrow. If he's awarded custody, then he'll be eligible. So really what it looks like this problem is doing is it's saying, look, we can see the C, arrow, E hiding in here. It's just simplifying it down. In fact, it looks like it's getting rid of these A's that are obviously redundant. Okay, but you can't just take them out. It's not like they cancel each other out. That's not exactly what's happening. What we need to do is we need to use our skill set based on the moves that we've got to go from this to this. All right, let's see what we got. First of all, do we have any arrows not in parentheses or brackets? And all brackets are just parentheses another level up. That's all they are. Next level up would be braces, and then these things start repeating. In a lot of British logic textbooks, they just use nothing but parentheses. They're just consistent in their application. That's fine too, if you want to do that. Okay, so do we have any arrows not in parentheses? No. There's an arrow here, it's in parentheses. Do we have any dots not in parentheses? Yeah, thankfully this one, right here. So what that's going to do is we can break this apart, and that breaks down the two sides. Thankfully, what that does is for this thing, it gets rid of the brackets. We're able to say A dot C, arrow E, that's one side, and out, line 1. And the other side is just A, also and out, line 1. Cool. Okay, can we do an arrow out now? Because look, now we have an arrow not in parentheses. There it is. Do we have a left side match? We're at 50%. We got half the key, we don't have the C. Okay, do we have a dot we can break apart? There's a dot right there. It's in parentheses. It's still locked. Okay, do we have anything we can put together? Yeah, we got a bunch of things we can put together. Any of it look like this? No. So what we need to do now is our emergency move. Is our golden arrow? Yep. So what we do in this situation, as we've been doing, is we're going to PA the left, provisionally assume it, and we're going to get the right. We can do that. We can be done with this problem. So let's do it. So we start our side quest. Line 4, we say, all right, we're going to try C out. It's a provisional assumption, and our quest right now is we're trying to get E by itself. Let's do it. He will be eligible. Prove it. Okay. Now, can we do an arrow out? No. Hopefully you can see here what you want to look for. Oh, the left side of this arrow is A.C. I don't have A.C. You got the pieces to build it though. But just to be consistent, let's go down the list. No, we can't do an arrow out right now. Can we break any apart any dots right now? No. Is there anything we should build? This thing. Literally, we put these two things together. That's the left side of this arrow. Let's do it. Build it. A dot C. What do we do there? And in. What were those pieces? 3, 4. Now, we get a left side match. That gets out E. Arrow out. The arrow we just used, that was in line 2. The left side match was in line 5. And hey, this E right here is the thing we were trying to get in the first place, which means side quest complete. So I'm going to zoom out here in line 7 and say, yeah, if you provisionally assume C, if you got a C, it'll lead you to E. You can totally stick the arrow in there. Where did that start? Line 4. Where did it stop? Line 6. Problem 8 is done. Now there are 2 versions of 9a. Let's try and do those. So these translations are a little bit more challenging on number 9, A, and B. So I'm going to go ahead and set us up with those. Let's do it. All right, let's do 9a. Okay, page 55, line 1. Reduction by police of the heroin supply is a sufficient condition. Oh, we haven't seen one of those in a while. For rising heroin prices. So we got the reduction by police of the heroin supply is a sufficient condition. Sufficient condition, first of all, that means an arrow, and whatever is the sufficient condition goes on the left side. In this case, it's the reduction of the police of the heroin supply. Is a sufficient condition for what? Rising heroin prices. Assumption number 1. Okay, assumption number 2. Second fact. Okay, addicts will need more money for heroin purchases if the price rises. So if the price rises, they'll need more money. But it's not done. And, it says and if. When you say and if, what that means is make a dot, go ahead and make at least another parentheses. Might need another bracket, but that means another arrow is coming, and another arrow is coming. So it might have more stuff in there than this, but a good provisor here is to go ahead and set this up this way. So what it says is, if they need more money, then they will commit more crimes. Assumption number 2. Thus, that means, here's what you're solving for. Thus, if the police reduce the supply of heroin, if they reduce the supply, crimes committed will increase. Yep, this is the paradox of the war on drugs. You make the drugs go away, crime actually goes up. It seems like the purpose would be like, hey, we're trying to stop crime. Let's get rid of things like heroin. The logic here demonstrates when these things happen, you get rid of supply, prices go up, actually crime increases as a result of trying to reduce drugs in an area. This has been demonstrated. In this particular case, this is about Philadelphia here on page 55. That's true in many other places as well. So regardless, let's prove that argument is true. First of all, we got any arrows not in parentheses? Yeah. Okay, left side match, nowhere to be found. Do we have a dot not in parentheses? Then, yeah, we do. So actually, we can go ahead and break this apart. Let's do it. And that's going to free both of these from their parentheses. We get P arrow N and N arrow C. That's an and out on line 2 for both. Okay, now we got 2 fresh arrows here. Left side matches for either of these 2? No. So now we got 3 arrows, no left side matches. Is there anything that we should put together? This is not a dot, so that's not happening. Alright, so then what's the next thing to do? It can't do any of the other 3 things. Our goal is an arrow. So what we're going to do is we're going to PA the left side, and we're going to try and get the right side here. So we begin our side quest. Line 5, S as a provisional assumption. Okay, in trying to solve for C. Okay, so with this S in place, do we have a left side match now? Can we do an arrow out? Yep, there it is. That unlocks P. Arrow out, 1 and 5. Okay, with that P in place, do we have another arrow out that we can do? Yep, there it is right there. This is the left side of an arrow. That's going to unlock the N. Okay, that's arrow out, 3 and 6. Okay, and then with the N here, look, this is another unlock. It's a left side match for line 4. That gets the C. Okay, and that C is what we're after in the first place, which means the side quest is going to be complete right here. So arrow out. Where was that arrow we just used? Line 4. Where was its left side match? Line 7. Here it is, side quest complete. So what I can do now is I can zoom out and I can say, yeah, you reduce the supply, crime's going to go up. How do I know that? Because you can stick an arrow in there. Where did that start? Well, we started by provisionally assuming S in line 5, and we got the right side of the arrow C in line 8. So this works. Let's now take a look at 9b. Okay, now with 9b, I'm not going to give you a problem the way this one is structured. So this one's like, oh, here's the conclusion, and here's the argument not put well together. So it's asking you, based on what the conclusion is and not a formalized version of the argument, figure out what the argument actually is. I'm not going to do that to you, but I'm going to, again, this is 9b, I'm going to show you what it actually is, okay? So I'm not going to make you do the translating part, but once we get the translating out of the way, this one's actually pretty easy. Okay, so line 1. Okay, so what it would be based on what's in italics there on page 55 is actually this. We would get this. Okay, T arrow D, and actually that's supposed to be a bracket there, so let me rectify that. We would get this, in brackets, T arrow D, arrow S, close brackets, arrow R. Assumption number 1. Okay, assumption number 2. Ooh, here's where things get tense. In braces, T arrow D, arrow S, arrow R, close braces, arrow, parentheses, V and P. Those are our 2 assumptions. Okay, actually what's hiding there, again, that's V and P. I know it looks from far away. It's a little bit hard to make out here. But yeah, so this is it. Now this one looks already, this line 2, this looks intense. What are we supposed to do? This is impossible to solve. This is actually super easy. Because check this out. Here's what I want to point out, how easy this actually is. Look what we actually have here. Like, to start, we've got this. Okay, so check it out. We've got, do we have any arrows not in parentheses? Yeah, this one here. Okay, now, this giant left side here. Do we have a left side match for this? Yeah, that's actually what line 1 is. That's all a match for this, which means we unlock immediately this, v.p. Like, so it looks difficult because it's big. Don't be intimidated by size here. Like, this is super easy. This is just a big key that unlocks this. That's it. Okay, and that's actually just arrow out. Where was the arrow? 2, left side match, line 1. That's it. It looks harder than it is. Okay, now, do we have any dots not in parentheses then? Yeah, I would say break them apart here. We actually don't need to, and I'm going to explain why here in a moment. Actually, we kind of do and we kind of don't. So let me just say this. So I'm going to say go ahead, just for the sake of principle. Let's break these apart. Okay, this is going to be kind of silly. I'm going to say this is the rule. We take them, we break them apart. V.P. Okay, that's and out on line 3, that V.P there, and that's also and out on line 3. All right, then we want to get T arrow V.P. Okay, can we do another arrow out? Nope, they've all been done. Can't add any more dots to break apart. No. Any more ants put together now? Doesn't seem like it. So what do? Is our goal an arrow? Yep. So we're going to start a side quest. And this one's going to go a little bit peculiarly. Okay? But it still works. So look, side quest starts. We're going to provisionally assume the T, because that's what we do. We provisionally assume the left side. Let me see, can we get the right? Okay? So we're going to provisionally assume T. And I'm going to say I want to get V.P. Now, in a sense, I already have it. And I broke it down. And so all I need to do is, if I can provisionally assume T, can I get V and P together again? Yeah. Just stick them back together. V.P. And in. 4 and 5. There is a way to do this without having to separate them, but I'm just going to say, for the sake of knowing our different moves, like if you can break the dots apart, go and break them back, back apart. And then the rule is simply this. Now, we didn't use the T at all. Like, we didn't have to use it in an arrow out or anything. We didn't use it. Does that mean this is invalidated? No, look, it just says, as long as you stick that T there as a provisional assumption, can you get the V dot P? Not that you have to use line 6 or use the T. Can you get V dot P? Bam, there it is. So that means, as quickly as you possibly could, side quest is done. And this is going to be ridiculously short. Look at this. We can say, yeah, you get T? Yeah, you can get V dot P. And you still stick an arrow in there. It's a short arrow to stick in, but you got it. And where did it start? 6, and it was over immediately. That works. And so this problem is done. Now, I'm probably not going to give you a problem like this where you have the conclusion and then you have to work backwards to figure out the assumptions. In fact, I'm not going to give you a problem like that at all. But in terms of problems that we're going to do next, the next one that I want to take a look at in here, not number 10, let's take a look at number 11. All right, number 11 works this way. It's found on page 56, and about in the middle of the page, number 11 has an S1 and an S2, and it says, prove that the S1 gets you to S2. So first we need to translate the S1. All right, this is actually a translation, I think, from when we were first doing arrows, and where I said it was kind of ambiguous which way it could be. What you're doing in this problem is proving, hey, the one ambiguous one actually leads to the other. So it says this. The first one says, S1, if you have a specific question, and it tells us where to put the parentheses here. If you have a specific question, then we will relay it to him if he calls in. Okay, so let's start with this. And then it says, okay, if you got that, prove that you can get, if he calls in, then if you have a specific question, then we'll relay it to him. Okay, so prove that these things can lead to each other. All right, fine. Okay, so let's do the moves. There's an arrow not in parentheses. Do we have a left side match? No. Do we have any dots we can break apart? No. Do we have anything we can build? No. Is our goal an arrow? Yes. So what are we going to do? Provisionally assume this. Get this. That's the mission. So let's start our side quest. Okay, with the provisional assumption of C, let's get Q arrow R. Okay, now, can we do an arrow out? No. Can we do an and out? Any dots? No. Can we do an and in? Yeah, we can put these two together. Does that get us anywhere? No. Is our goal right now an arrow? Yes. So what are we going to do? Provisionally assume this and get this. All right, let's start this side quest. Okay, so Q, provisional assumption. What we're after right now is R. Let's do it. Now with this Q here in place, can we do an arrow out? Yep, finally. This unlocks this. C arrow R. Okay, how? That's arrow out 1 and 3. Okay, now this here, here's a new arrow. Do we have a left side match for this one? Yeah, line 2. That unlocks what? R. Hey, that's the thing I wanted to get. So I'm just gonna say how I got it. Arrow out. The arrow I used was in line 4. Its left side match was in line 2. This side quest is complete, and so I'm going to zoom out and say what I can do. Yeah, if you have a Q, then you can get to R. You can stick the arrow in there. Where do we start that quest? Line 3. Where do we finish it? Line 5. And look, this is actually the fulfillment of this side quest, which means this led to this, which means I can zoom out and say, hey, if you have a C, it will lead to a Q arrow R. You can stick an arrow in there. Where do we start that quest? Line 2. Where do we finish it? Line 6. This problem is done. Next thing I want to do is number 12. All right, let's do number 12 here. We got to translate. Okay, if the windows are open, we get hot air. That's an arrow. So if the windows are open, we get hot air. That one's pretty straightforward assumption. Okay, 2. If the air conditioner is on, we get noise. Yeah, true. My air conditioner, for example, is running right now, incessantly during the summer. I have to change the filters out every couple of weeks. And it's loud. I don't like it. Then it says this. It follows that. So here's what we're solving for. What? If, so that means there's an arrow. If the windows are open and the air conditioner is on, So that means on the left side of the arrow, we got a dot. If the air conditioner is open, I'm sorry, if the windows are open and the air conditioner is on, then we have the following things. We get both hot air and noise. Furthermore, I'll just add, that's stupid to have the air conditioner on and the windows open. Not if you're in a car, I kind of get that. You're trying to get the hot air out, like right when you get in, you're blowing the cool air on your face. That makes sense to me. But in your house, you're throwing electricity out the window, or throwing money out the window, I suppose, paying for electricity. All right. So that being said, let's do the work. Got 2 arrows here. Left side matches for either. Nope. Any dots we can break apart? Nope. Can we put these two together? We can. Should we? No reason to. Putting these together is not this. It looks like the same amount of stuff, but that would be O arrow H and C arrow N. It's not the same thing. So then we look at this. Is our goal an arrow? Yep. So what we're going to do is we're going to PA this, and we're going to get this. That's what we're going to do. Let's do it. So let's start our side quest, line 3. Provisionally assume O.C, and we're after H.N. That's the mission. So now, with this in play, can we do an arrow out? Still no. Any dots that are new? This is new. Let's break that down. That gives us 2 things. O and C separately. And out on line 3 for both. Okay. Now can we do an arrow out? 2 sets. There's one lined up. There's one lined up. Does it matter which one we do first? No. But like I said, I personally prefer to do the one that comes first. So I see those matching O's there. That's going to unlock the H. Let me get that out. H. Arrow out. 1 and 4. And then we got another one. See here, that's the left side match for this. That's going to unlock the N. Okay, so N. Arrow out. 2 and 5. Okay, so go back to the list. Any more arrows for which I got left side matches? No, no more arrows, no more left side matches. Any more dots to break apart? No. Anything that I should build? Now again, right now, what we're after is actually a dot. And I said 99% of the time, when you're looking for a dot, you're probably going to put it together with an and in. And look for right here. Do a check. Do I have the pieces to build this? Yeah, we just got them. All right, that means, yep, let's do it. H.N. Put them together. And in. Where were those pieces? 6 and 7. And that means here we got what we set out to get. Side quest complete. Zoom out. Okay, say, hey, yeah. You got O.C? It will totally lead you to H.N. How? You can stick an arrow in there. Where did it start? Line 3. Where was the mission complete? Line 8. And the problem is done. So, number 13. Here I'm not even bothered with the translation. It's there on page 13, but it doesn't really start with a translation that's suitable for us. Like, you can see it there. I think that is interesting. It comes from the quantum mechanics, but I think it ends up being frustrating to translate it as it is on the page. So here's what it is, and you can go back and figure out like what the actual argument is based on the terms that are there. But let's solve the proof as such. Okay, so first of all, any arrows not in parentheses? Nope. Any dots not in parentheses? Yeah, right there. What does that do? That breaks down to these 2 things. T arrow L, T arrow M. That's and out. Line 1 for both. Okay, now we got these fresh arrows here, not in parentheses. Do we have a left side match for either one of them? They got the same left side. T? No. Okay, no, we can't do that. Any more dots to slice apart? Nope. Anything that we can put together? We can put a bunch of things together, but that doesn't squash down into this. So then we move to the thing that we've been doing a lot here. Do we have an arrow as our goal? Yes. So what do? Provisionally assume the left side. Get the right. Let's do it. Side quest begins. Line 4. T. Provisional assumption. Get L.M. It actually ends up being pretty easy. Watch this. Because now we can do an arrow out here. What do we get? L. Arrow out 2 and 4. And then immediately thereafter we get, look, another arrow out with T. We get M. Because we can use that line 4 as many times as we want. It doesn't exhaust. 3 and 4. So now we got L and M. And remember, I said before, when we're trying to get a dot, odds are you're going to use an and in. Now let's just make sure. Any arrows? No. Any dots? No. Should we build something? Yeah, we're trying to get L and M. We got the pieces to build it, so let's build it. L dot M and in. Where's our receipts for those pieces? Line 5, line 6. Side quest complete. So now I zoom out, and I can say, yeah, you get the T, you will get L and M. Okay? That can be proven in this way. Where did we start? We started on line 4 with T. Where did we get L and M? Line 7. Problem 12 is now complete. So now what we're going to do is we're going to move on to problem 14, which is the same thing but in reverse. So we're going to start with T arrow L and M, and we're going to get T arrow L and T arrow M. See if that works. Okay, let's do it. All right, let's do number 14. It's the same thing as number 12, just in reverse. All right, we're starting with this one, trying to get to this one. So let's see. First of all, arrows. Left side matches? No. Dots? There's one, but it's in parentheses, so no. So then we move on to the next thing to do, which is this. Is our goal an arrow? No, it's not. It's not. It's an and. Oh dear. What do we do? Well, keep this in mind. All right, so this one involves a little bit of some backwards thinking, and we need to think this. I'm going to think of it this way. I'm going to go ahead and remind you, like when it comes to, so can we do an arrow in here? No, not as it is. This is a dot, not an arrow. Our goal is not an arrow. What do we do? There's still something we can do here, because I want you to remember this. I said when our goal is a dot, 99% of the time, what we're going to have to do is an and in. Okay, that's true. Okay, and in fact, the last move of this problem will be an and in. 100% certain of that. Okay, an and in of what two things? What two things would we need? Well, we'd need to get T arrow L, and we need to get T arrow M. Do we have either of those things? No. But look, both those things are arrows. So all we got to do, and so this one requires a little bit of extra thinking, but all we got to do is if we could get a side quest for this, and then a separate side quest for this, all we got to do is stick them together, we'll get that. That's it. So it involves a little bit extra thinking, and at first glance, it's like, oh no, what do we do? What do we do? What do we do? And we haven't had a problem like this one. But let's watch. Now, when it comes to the side quests, I'll say this, with side quests, or the subproofs, you can't mix and match between them. So a side quest is its own ordeal. Okay? It's its own quest. You can't mix and match. Here's what I mean by that. Let's go ahead and start this one. Let's start getting this one first. So look, let's say we want to get T arrow L. What would we do for that? Well, we provisionally assume T, and then we want to get L. Let's do it. So let's start. Line 2. We're going to provisionally assume T, and we want to get L. Okay, that's the mission. So, can we do an arrow out now? Yeah. What do we get? L.M. How? Arrow out. 1 and 2. Great. Now what do I want to get? L. So what can I do here? Look, I have a dot here now that I can separate. Now I'll just say here, what we can do, we can just get out the L. We don't even need the M. If you want to stick it there, that's fine. It's not wrong. You'll see why I'm not going to do it here in a minute. But yeah, we can just get the L out, and I can just say and out line 3. I don't even bother getting the M out because I don't need it. Like, mission accomplished. I did it. Side quest complete here. Look, side quest complete. You got T, you get L. So look, I can zoom out here and say, yep, T leads to L. Arrow in, 2 through 4. It works. And look, now I got half of what I need. I'm 50% there. What else do I need, though? I also need T arrow M, which is going to need its own separate side quest. Now, here's the deal. When you start this side quest, all this stuff in this one that we already did, this side quest, part of the reason why I put like a bar here like this is all locked. This is its own. It's kind of like parentheses. This is its own thing. You can't dig into here. Number 1 is free to use. Number 5, like the stuff that's in the main quest, that's free to use. This stuff here, that's like its own currency. Okay, kind of like your Monopoly money doesn't work in real life. This is its own thing. The side quest stuff here, it's its own stuff. So here's what I mean by that. Let's start this quest. We want to get T arrow M. It's going to be its own separate ordeal. Look, so let's start. 6, T, provisional assumption, get M. Now you might be thinking, well, I already provisionally assumed T up here to get L. Why am I doing this? That was its own separate thing. That was this mission. This is a different mission. It's repetitive. Sometimes that happens. Sometimes we do similar things. Like, have you ever driven to work more than once? Maybe you had to take a different turn. Like, it's similar. It's kind of repetitive, but it's not identical. Let's do this quest. Well, I already got it. Like, I already got it here. I already got L dot. Nope. That stuff is locked off. That was its own separate quest. So now you're only dealing with line 1. You're only dealing with line 5. Can we do an arrow out right now? Now, we can actually do an arrow out with this one. Don't, because we're after M. So that would be a waste of time. We can do it. It wouldn't be wrong, but it's not going anywhere. Let's do it. Can we do an arrow out with line 1 again? Yes, and we get L dot M. And again, your gut reaction might be, we already got it in line 3. Separate side quest. All that was done. It's done. We can't re-access this stuff. It did what it needed to do, but we can't tap back into there. It's locked. Okay? How do we get this L and M? How do we get it this time? It was an arrow out between 1 and 6. Okay, because here's where this one started. So this is a separate quest. Okay, line 8. Let's just go ahead. We can just take the M out. We can take the L out too. But just like here, we just took the L out when we needed it. We didn't need the M. Here, it's kind of the opposite situation. We don't need the L. We do need the M. Let's get that out. So check it. And out. Line 7. Look, this mission is complete. We did it. We assumed T. We got M. We already had it here. Separate quest. Different mission. Different goals, different rules. Now this is closed off too. So what do we get here? We zoom out. We can say, hey, we got T arrow M. How? Well, we stuck an arrow in there. We provisionally assumed T in line 6, and we got M in line 8. Now look at this. Now the main quest is this. If you got this, and you got this, and you got this, what can you use to get to this? Do we have now the pieces to build this? Do we have T arrow L? Yeah, we got it in line 5. Do we have T arrow M? Yeah, we got it in line 9. So guess what? In line 10 here, we can just add those in. Yeah, we can take line 5, T arrow L, and we can take line 9, T arrow M, and we can just add those in, and in, 5 and 9. Now, this one was tough. This one was tough because it wasn't obvious that's what to do. Okay, so here when we get to it, there was almost a situation here. Can we do an arrow out at the beginning? Can we do an and out? Can we do an and in? Can we do an arrow in? And it seemed like the answer at first was no. Because, yeah, that's not the immediate move. But then when you get stuck in a situation like that, we have to figure out, and this is where logic comes in handy, well, what would I need to make this happen? And so here, I told you before, I've said it many times, if what you're looking for is a dot, then 99% likelihood you're going to and in. And then we figured out, okay, we need to and in these two different things here. And those are both arrows. And those can both have arrow ins. And that's exactly what we did here. So I'm showing you how, when you get in a situation where it looks like this is impossible, there's no way to do this, it's kind of like a puzzle. Figuring out, like, all right, this is what I need to do. So you might have a problem like this on your quiz. But the point is here, if you get stuck, again, look at the conclusion. If it's a dot, 99, if it's an and like this, a dot, conjunction, that's what I mean. If you see something like that, there's 99% likelihood you need to and in these two things. And if you ever need an arrow and there's nothing else you can do, like I can't arrow out, I can't and out, I can't and in, do this arrow in thing. Provisionally assume the left, get the right. Okay? All problems on this quiz are doable. So there's nothing that's impossible, I assure you. They're all doable with just these 4 moves. Every single one. Okay? In fact, speaking of more problems, more moves, let's move on to the next one here in the book. All right, let's take a look at number 15. So, first of all, I've translated it for us because it's a bit confusing as it is, but I want to focus on actually doing the problem here. So do we have any arrows not in parentheses? Here and here. Any left side matches? Nope. So, moving on. Do we have any dots not in parentheses? Actually, yeah, we do right here. So what we can do is we can go ahead and separate this. That gets us lines 4 and 5. Okay, so we got C arrow P, now unlocked from its parentheses, and we get C arrow N unlocked from its parentheses. Both of those are and out on line 1. Okay. Now, now can we do an arrow out? We got more arrows now. We got these C's. Can we do an arrow out? No. Can we do another and out? There is another and, but it's locked in parentheses. Can we do an and in? Well, our goal is not an and in, so that's not going to get us anywhere. So is our goal an arrow? Yes. So what are we going to do? We're going to PA this, and then we're going to try and get this. If we can do that, we're good. Let's do it. So we start our side quest, line 6. We're going to say, all right, C as a provisional assumption, and we're going to try and get E. That's the mission. We do that, we're good. Okay, now with the C here, can we do an arrow out? There's 2 that we can do. C is the left side on both line 4 and line 5. Does it matter which one we do first? No, but I'm going to do it in the order that they come, so I'm going to go ahead and get the P out first. So we got P. That's arrow out. The left side match. The arrow is in line 4, the left side match is in line 6. And then I'm also able to get out N. Arrow out. The arrow that I used there was in line 5, and the left side match was also in line 6 again. Alright. Can I do another arrow out? Well, not yet. Can I do another and out? No. Can I do another and in? Well, let's take a look. Is my goal right now, or my ultimate goal an and? No. Is my goal at the moment an and? No. The next thing you want to look for, are there any ands on the left side of arrows? Yep, line 2. P dot N. Do I have the pieces to build that? I just got them. So let's build it. Line 9. P dot N. That's and in. And I say, where did I get my pieces? Line 7 and line 8. Okay, now can I do an arrow out? Yep, this is the left side match to this. That gets me U. Arrow out. Now these are kind of far apart, but look, nevertheless it works. This is the left side match to this. It unlocked the U. So when I say the arrow that I used was in line 2, the left side match was in line 9. And now with this U here, go back to the top of the list. Can I do another arrow out? Yeah, line 3. U's on the left side of the arrow. We just got a U. That's going to unlock the E. So I say E. Okay, that's arrow out. That arrow that I used was in line 3. The left side match was way down in line 10. And look, I got the E. That's the thing that I set out to get. So this took a bit more work to do it, but the quest is complete. So now I can zoom out and say, yeah, line 12. You provisionally assume C, you'll get E. It'll take some work to get there, but you can stick an arrow in there. Where did it start? Line 6. Where did it stop? Line 11. This problem is now done. Let's take a look at the last one that I want to look at from the book, number 16. Right, here's number 16. Let's translate it and work our way through it. So, first line. This is on page 57. If the doctor goes, I go too. And here it says the strong man is talking, so it has a weird glossary. The strong man is the person talking in the first person, and the strong man leaving or going is going to be represented by S. It actually says that after the problem. It's kind of stupid. I don't like that, but that's what we're going to roll with. So line 1 would be, if the doctor goes, so that's an arrow. If the doctor goes, then I, the strong man, go too. Assumption number 1. Assumption number 2, on the other hand. And if I go, that and there is superfluous, but it says if I go, so if I, the strong man, go, then what? The trapeze acrobats, they'll go too. Line 3, the exodus of the trapeze acrobats and me will cause. That means if they go and I go, then that will cause the Hop the Clown to leave. Assumption number 3. Our leaving, and I'm going to do it in the order that it comes. It says, if I leave the strongman, if the trapeze acrobats leave, and if Hop the Clown leaves. So all that's on the left side of an arrow. Then what? It will result in a reduced circus. Assumption number 4. Now, is this dyadic? No. So if all this stuff happens, then it will result in a reduced circus. So is this dyadic in here? No. So it's all dots though, so I have an option. I can either put parentheses around the S and the T, or around the T and the C. I am just going to decide to do around the S and the T. No real reason there. Just now this is dyadic. Here's a big left, tiny right. Then it says, so that means here's what we're solving for. If the doctor goes, that will result in a reduced circus. So we've got these facts. We're going to try and get to this. Do we have arrows? Oh, yeah, we do. We got a bunch, not in parentheses. We got 4. Any left side matches, though? Nope. Are there any dots that we can break apart? Nope, all the dots that are here are in parentheses. So that means we're going to look and see, is our goal an arrow? It is, and so what we're going to do is we're going to PA the left side, and we're going to get the right. So let's begin the side quest, line 5. We're going to provisionally assume D, and the mission is get R. We do that, we're good. Now with the D here, now can we do an arrow out? Yes. We get S. Okay, arrow out. 1 and 5. Okay, with the S, can we do another arrow out? Yep, that's the left side here in 2. So we get T. Arrow out 2 and 6. Now can we do another arrow out? No. We got 2 other arrows here, but we don't have them. We don't have T and S, and we don't have S and T and C. Do we have the pieces to build one of these? Not that one. Do we have the pieces to build T and S? Yep, we just got them. Let's build that. T.S. Now we got it. How do we do that? And in 7 and 6. Now does this now unlock an arrow? Yep, this one unlocks now C. Arrow out 3 and 8. Great, now I got C. Now, can we do another arrow out? No. Can we do an and out? No. Alright, I mean we can and this out again, but that would already get us pieces that we already have. Okay, so what's the next thing? And in. Can we do it? Actually, yeah, look at this. We've got S.T.C. That's something we can build. It's all dots, and we have S, T, C. We have all the pieces. We just need to build it. And here, I know we just built T and S, or T.S, but this one's in a little bit of a different order, so we're going to have to rearrange it. Again, it's kind of similar to, we've got the right key, we just have to turn it over and add something else to it. Let's start building what we need for the left side of line 4. So the first thing we need to get is, I know we already got S.T, but we already got T.S, let's get S.T. Okay, why? Because that's half of what we need for the left side of line 4. So that would also be and in line 6 and line 7. And then we're going to adjoin C to this. So check it out. Line 11, we're going to say S and T. We're going to adjoin C to that. And in 10 and 9. Okay, so look, now we've got here this thing we just built in line 11. Why do we build this? Because it's the left side of line 4. What does that get us? R. Look, so this is a left side match for this monstrosity in line 4. That gets us R. How do we get R? Arrow out. The arrow was in line 4. The left side match was in line 11. And look, that's the thing that we were trying to get here in line 5 in the first place when we did a provisional assumption. So this was a long side quest, but the result is line 13. I can zoom out and say, yep, If you provisionally assume R, I'm sorry, if you provisionally assume D, you will get R. Arrow in. Where did it start? Way up here in line 5. Where did it end? Way down here in line 12. The problem is done. So now that we've gone through a bunch of the problems in the book, I'm going to do a couple of problems that will actually be on the quiz that's on all 4 of these rules. Arrow out and in, arrow in. And also some of the stuff on translations, everything going back to ands, words that mean and also the stuff on sufficient conditions, necessary conditions, and the notion of only if. Okay, let's do it. All right, let's look at this first sample problem from here, quiz 3. So here, this is an actual problem from quiz 3, and the stuff that would be represents statements is already here in all caps. I'm going to underline it just to be even more forceful here. And there's a couple things I want to note. Everything that I've circled is, and this will be italicized on your quiz. So everything I've circled here, any connective language where it means anything like an arrow or a dot or parentheses, I've circled here in some way. Something to let you know, like here's a symbol you need to put up. All the statements here are both all caps, and I've underlined them too. So here's what we got. Let's just go through it. It says first thing is if. That means, hey, there's an arrow. If what? Whatever follows if goes on the left side of the arrow. If someone says they like Star Wars, and we see the word then, that means, hey, someone says they like Star Wars. That's on the left side of the arrow. Then they're a what? They're a geek. Then we see a semicolon. Okay, now I'm using semicolons to let you know that, hey, if there's a semicolon here, look and see, do you have more than one thing on the left or right of the semicolon? If you do, if you have 2 things to the left of the semicolon, it means it needs to have parentheses. If you got 2 things to the left of it, it needs parentheses. If you got 2 things to the right, it needs parentheses. Okay, so this is, I'm using a semicolon to help you know, hey, here's when stuff needs to go together. So let's take a look. To the left of this, are there 2 things to the left of the parentheses? Yeah. I'm sorry, are there 2 things to the left of the semicolon? Yeah, there's W, there's G. That means this goes together. And then it says and if. And I told you this. When you see and if, what that means is there's a dot and then there's another arrow. That also means, I said here, if there's a semicolon and there's at least 2 things on the right, and there's another thing, that means you're going to have parentheses here on the right too. We also know that because of the and if situation. So then whatever follows this if is going to go on the left side of the next arrow. If someone says they like Star Trek, then they're a nerd. That's this problem. So I'll say it back. If someone says they like Star Wars, they're a geek. And if someone says they like Star Trek, then they're a nerd. Okay, so this is an example of a problem on quiz 3. This is an actual problem there. It's not just like, oh, you'll have a problem like this one. This is an actual problem that you'll have on quiz 3. I'm going to give you a couple of others. So this is just a translation one. Okay, let's take a look at another sample problem from quiz 3. So this one says, there's a lot of words going on here. Let's break it down. So everything here that is all uppercase, that is stuff that represents simple statements unto themselves. And then the stuff that's circled represents connections. So wherever you see something circled, that means there's going to be an arrow there or a dot or something. It means something. Or even the semicolon here means something to do with parentheses. So let's just go through it straight through, see what we can figure out. This is an actual problem from quiz 3, so I'm giving it to you to give you an example of here's what you're going to encounter. So it says this: Big Kahuna Burgers blow out Hawaiian Bacon Bonanza Burger is both high in fat and cholesterol. So then there's a semicolon. So let's get this far. So Big Kahuna's burgers blow out Hawaiian Bacon Bonanza Burger is both, let's hear, hey, there's a dot coming. It's both what? High in fat and cholesterol. Then there's a semicolon. Now the semicolon tells you to do this for me. If there's more than 2 things to the left, you need to put them in parentheses. Hey, there are. And if there's more than 2 things to the right, you need to group them together too. So what's the next thing we see? If all of the preceding, which means, by the way, all of that is on the left side of the arrow. And then let's see, how many letters do we see after that? E, H, and D, which means that's more than two things. That means there's going to be brackets on the right side. Okay, because that semicolon means everything to the left of this is grouped together and everything to the right of this is grouped together. You see two things, that calls for parentheses. You see three things, that calls for brackets. Four things, that calls for braces. More than that would call for another order of grouping. So we know we've got this. So let's zoom in here to see what we'd have. If all the preceding, also, if all this happens, so all that's on the left side of the arrow, then what? Then we see then if. That means there's an arrow in here. Okay? And then whatever follows this if goes on the left side of the arrow. If you eat it. Then. Okay, so everything that follows this is going on the right side of the arrow. Your heart could very well explode. Moreover, what does that mean? Oh, that's one of those fancy words that means and. Which means, by the way, here's a grouping. Moreover, you could die after one bite. There it is. So this is it. So look, this burger, so all this nonsense, Big Kahuna Burgers, Blowout, Hawaiian, Bacon, Banana, like this thing is high in fat and cholesterol. If that's true, then if you eat it, then your heart could explode and you could die. That's what this is saying. And this is the correct translation for this. So, I've done two translations. Now let's look at a translation into a proof that will be on quiz 3. Okay, let's now do a translation into a proof. We got this one. I will stare into the eclipse only if it burns my eyes. Only if. Draw an arrow right over it. You won't mess it up. So then translate it exactly as it is. I will stare into the eclipse only if it burns my eyes. That means E, arrow, B. Line 1. E, arrow, B. Assumption number 1. Okay, period. Line number 2. Burning my eyes is a sufficient condition for needing retinal surgery. Sufficient conditions go on the left side of an arrow, which means line 2 is going to be an arrow. What's the sufficient condition? Burning my eyes is the sufficient condition. For what? Needing retinal surgery. Assumption number 2. And then it says, so, which means this is the conclusion. So we're solving for this. Getting retinal surgery is a necessary condition for staring into the eclipse. Well, necessary condition means there's an arrow, and whatever is the necessary condition goes on the right side of the arrow. So this goes on the right side for E. So here in this problem we have sufficient condition, necessary condition, and only if. Okay, let's go ahead. Now we've translated it. That's half the work on this one. We need to also solve for it. So first of all, let's see. Do we have any arrows not in parentheses? Oh yes, 2. Do we have a left side match for either one of these? Nope. Any dots we can break apart? Nope. Anything we can bring together? We can bring these together, but we're not looking for a dot, so we're not going to bring these together. So what do? Is our goal an arrow? Yes, it is. So what we're going to do is we're going to provisionally assume this, and then we're going to get this. If we do that, we're good. So let's begin our side quest. Line 3, E. Provisional assumption, and we're after S. Okay, so now with this E in play, can we do an arrow out? Yep, there's a left side match right there that gets B. Arrow out 1 and 3. Okay, with this B in play, can we do another arrow out, left side match? Yep, we got one right there. That's going to unlock the S. Okay, arrow out. Where was that arrow that we used? Line 2. Where was the left side match? Line 4. Great. And look, we got the S that we sought to get. So side quest is done. So then what we do is we zoom out and we can say in line 6, hey, if you get E, if you have E as a thing, you will get S. And we can prove it. Arrow in. Where did that start? Line 3. Where did it stop? Line 5. And thus, this problem is done. This is a problem that's actually on quiz 3. And let's take a look at one more. That's just a straight up proof, no translation that we have to do. Let's do it. Okay, what we've got here is this is what a proof will look like on quiz 3, just a straight up proof. Not everything's laid out. We're going to have to lay it out. But this is the problem. You got this one. This is assumption number 1. This is what these commas mean. Assumption number 1, assumption number 2, assumption number 3, assumption number 4. Solve for this. So let's lay it out. Line 1 is just J by itself as an assumption. Line 2 is K dot L, assumption. Line 3 is going to be J arrow, brackets, parentheses, K dot L, arrow I, close brackets, assumption, and then assumption number 4, I arrow H. And then it's solve for H. That's what we're solving for. So get that out of this. So let's see. First of all, do we have any arrows not in parentheses? Let's do the work. We got 4 things in play. We got arrow out, and in, and then arrow in. Any arrows not in parentheses? Yeah, line here, line 3, line 4. Do we have left side matches for either of these? Yeah, line 3. We got it right there. So we can go ahead right now and unlock the right side here. So this is going to free it from its brackets. We get K dot L, arrow I. That's arrow out, 3 and 1. So this is a new fresh arrow. Okay, so for this one, do we have a left side match? Yeah, we do. Line 2, there's K dot L. So line 6, we can say we unlock the I, because here's an arrow. We got a left side. We got a left side match. We got the I. That's arrow out. The arrow that we used was in line 5. The left side match was in line 2. Now, with the I here, can we do another arrow out? Left side match. Yeah. 4 and 6. We get H. That's what we want to get. We get H. Arrow out. Where was the arrow that we used? Line 4. Where was the left side match? Line 6. And without an and out, without an and in, without an arrow in, this problem is done. We're good. Alright, problem solved. This is another sample one from quiz 4. So now you have a sense of the problems that we've gone through, which were many, and we have some from the quiz itself. So now you should be all set up for quiz 3. Okay, next thing we're going to be moving on to is the notion of negations.